Okay, let's continue. We'll study the area of a triangle. So, consider a triangle ABC. We can ask what is the area of the triangle? So, we'll first consider a simpler version of the problem. So, consider a right angle triangle. So, this is a right angle triangle. The side opposite to angle A, we can suppose it has length A, and the side opposite to angle B, suppose it has length B. Okay, now we can ask the same question. What is the area of the triangle? What is the area of triangle ABC? So we'll proceed. So we have triangle ABC. What we'll do is construct a line through A parallel to BC. And a line through B parallel to AC. So construct a line through A parallel to BC and construct a line through B parallel to AC. So call the intersection point D. Or I'll write it here. Call the intersection point D. Right. So we can ask, is ADBC a rectangle? Intuitively, it seems like it should be a rectangle. We have to prove that. So let's see. So we have angles in this diagram. You have triangle ABC. And you have constructed line through A parallel to BC and line through B parallel to AC. And call the intersection point D. Now we have this equality of angles. This angle is same as this angle because the lines are parallel, and even this angle is equal to this angle. Hence, for example, measure of the angle at D is equal to 180 degrees minus this angle. You're subtracting both these angles from 180 degrees. That will give you the measure of the angle at D. But this is equal to, but this is further equal to 90 degrees, right? Because in the original right angle triangle, these two angles sum up to this dashed angle and this double arc angle. Both of these sum up to 90 degrees. So hence measure of the angle at D is equal to 90 degrees. Similarly, in the rectangle, measure of the angle at A, and so measure of the angle at C and the measure of the angle at B. Yeah. All of these are 90 degrees as well. Hence our question is ADBC is a rectangle. Is ADBC a rectangle? The answer is yes. Hence ADBC is a rectangle. So in this rectangle, in this rectangle ADBC, yeah, so you have two copies of the right angle triangle. There are two copies of the right angle triangle. Two copies of the right angle triangle form this full rectangle. Hence area of triangle ABC is half the area of the rectangle ADBC, which is just half. So this length is A and this length is B. So this is just half AB. So area of a right angle triangle is just half AB, half the length, half times the product of the arm lengths, right? Half the product of the arms of the right angle triangle. So we have this observation. Area of a right angle triangle. Consider a right angle triangle. Then the area of the right angle triangle is just half AB, right? So this is an observation. So we can ask, our original question was, how do we find areas of general triangles? What is the area of a general triangle ABC? So we'll get back to that. Sorry. Yeah. So we have an example. Consider this example. Consider a triangle So consider this triangle. Then area of the triangle is area of the big right angle triangle, so which is half B2H, minus the area of the small right angle triangle, half B1H. This is the area of the triangle ABC. Alright, area of triangle ABC is equal to half B2H minus half B1H is equal to half B2 minus B1H. Hence, in this triangle, if we call h the height and this length to be the base B, the area of the triangle ABC is half BH, right? So yeah, in this situation the area of the triangle ABC is half base times height. So we can consider another situation, another configuration. Consider a triangle the height is h and this length is B1 and this length is B2. Then the area of triangle ABC is half sum of the areas of these two smaller right angle triangles, right? So it is half B1H plus half B2H. This is half B1 plus B2H. Hence, in this configuration, right? So in this configuration, the full base is called B. Then the area of triangle ABC is half B1 plus B2H, which is just half BH. So in both these configuration, in both these triangles, area of the triangle is half base into height. So in this triangle, area of the triangle is half base into height. In this triangle, area of the triangle is half base into height. And in a right angle triangle, area of the triangle is anyways half base into height. Hence, in general, we have the observation so the observation is area of a triangle is in general half times whichever base you choose times the corresponding height. So area of a triangle is half base into height. This is the general observation. Okay, so yeah, so that's all for this part. See you in the next part.